Alright, today's lesson is lesson number 74. We're going to continue solving quadratic equations. So yesterday, or I guess Friday, we started the lesson with factoring, solving by factoring. Yesterday, you guys continued with graphing. And today we're going to talk about how to solve quadratic equations by taking a square root. Okay, so this is almost actually a little easier than some of the other methods, so hopefully it's not too bad. We're going to start off by first identifying when this is a good method to use. Okay, so it happens when our b is equal to 0. So if we have ax squared plus bx plus c equals 0 as our standard quadratic equation, we can use this when that b term is equal to 0, okay? So basically, whenever we just have a squared and constants. Okay, so this would be an example. We have 3x squared, and then the other two things are constants. So we could use it in that case. First thing you're going to do is isolate the variable for this equation. That would look like this. So you'd get x squared equals 17 over 3. Then if the variable is squared, you want to take the square root of both sides. So that would give you square root of x squared equals the square root of 17 over 3. And then you want to write two equations. So you're splitting this up now. You say x equals, if I'm saying, okay, well, something squared gives me 17 thirds. If I have x squared equals 17 thirds. Before I take the square root, I'm thinking, okay, I want to know what number squared gives me 17 thirds. And I know that I'm always going to have a positive case and then a negative case, right? So I take the square root of both sides, and I look at this as x equals either the positive square root of 17 thirds or the negative square root of 17 thirds. Those are my two equations, and they're already both solved for x. So that would be my answer. Okay, we'll see plenty more examples of this. Okay, so write down the steps in your notes if you don't have them. Numbers 1 and 2, I would start number 1 by adding 7 to both sides in order to start isolating the variable. Okay, then I'm going to divide both sides by 2. I get x squared equals 64. And I'm thinking, what number squared gives me 64? Well, I could do positive 8 or negative 8. This one's kind of easier, right, because it's a perfect square, but I'm going to go ahead and do it neatly. I'm going to set up my two equations, right, so either x is the positive square root or it's the negative square root. So x equals 8 or x equals negative 8. Okay, and if we work back through the problem, that makes sense since 8 squared gives us 64 and negative 8 squared gives us 64. So multiplying by 2 gives us 128. Subtracting 7 would give us 121. So both of those numbers work as solutions. Okay, number 2, I'm going to start by subtracting 6 to both sides. That gives me 3m squared equals 39. I'll divide by 3 to isolate m squared. And then take the square root of both sides, set up my two equations. I have m equals the positive square root of 13, and m equals the negative square root of 13. If I want to be kind of fancy or lazy as a mathematician, I don't have to write two answers. Instead, I can squish them together and write this just as x equals plus or minus 8. Okay, so I could, this says or that. Okay, so you can give these two solutions, or you can just give this, which is, it's also two solutions, but it's written as in one line. Okay, it's a little neater. Same thing with number 2. I can say m equals plus or minus the square root of 13. All right, so make sure you have these written in your notes if it's your first time with this lesson. And we'll move on to example number 3. Again, isolating the r squared first. So students did this on their own or with their partner in class today. They got 3r squared equals 108 by subtracting 4. Then by dividing 3, they got r squared equals 36. When we go to take the square root of both sides, we have to consider the positive and the negative case because both of those squared will give us 36, right? So I know either r equals the positive square root of 36 or r equals the negative square root of 36. Which tells me r equals 6 or r equals negative 6, which I could write as my final answer together for r equals plus or minus 6. Number 4, I start by adding 1 to both sides, and students did number 4 completely on their own, so try to do this beforehand if possible. I add 1, divide by 4, that gives me k squared equals 38. Taking the square root of both sides, I know k equals the positive square root of 38 or the negative square root of 38, so I can combine that into one answer for k equals plus or minus the square root of 38. So square root of 38, I can't simplify that at all. It's not a perfect square, so I just leave it as is. Okay. Now, moving on, numbers 5 and 6. Number 5, again, students did on their own, so we were looking at this. Oh, sorry. Number 5, here we go. So we just did number 5 in class. If I subtract 7, that gives me 3x squared equals negative 38. Dividing by 3, I get x squared equals negative 38 over 3, or negative 12 and 2/3, either way. It's both are correct. If I take the square root of both sides, I get x equals the square root of negative 12 and 2/3. Square root of a negative, I can't do this, okay? If I have a positive times a negative, that gives me a negative, right? I can never have a positive number and a negative number that are the exact same, so I can never get a negative inside my square root, right? It doesn't exist. So I say x doesn't equal anything. I have no real solution. If I consider graphing this, I might add 31 to the other side so that I have 3x squared plus 38 equals 0. The graph of that would very roughly look something like the graph that I've sketched here. And it'd be facing up above the x-axis, so there would be no real solution here. Clearly, you would be able to see from the graph because there's no x-intercepts, right? When it's equal to 0, it's never equal to 0. It's always above. So that is all for the lesson part of today. We also took some time for independent practice in some of the classes, so if you didn't get a chance to complete this, go ahead and work on some of these problems now so that you can check your work. I'm going to show the answers here shortly. That way you can see if you're on the right track for the homework problems, okay? So here are the problems, and pause here if you don't want to see the answers quite yet. Okay, and here are the answers to those 8 problems, okay? This fractional piece, or actually let me start with number 5 right here. This you might get down to square root of 20 or plus or minus the square root of 20. Square root of 20 is just the square root of 4 times 5. 4 is just 2 times 2. And remember, when we have 2 of the same thing, they get to break out, but only one makes it, so we have 2 root 5. Okay, so if you get to this answer, that's correct, but